Good afternoon, my name is Saxon Dofiri, and here to demo Lab 4, which is my 4-bit input calculator in which it can add and subtract. Here are my test cases just to make the demo easier to look at. And here is my 7-segment display, and the LED will turn on when it's negative. You'll see it later in the test case demo. This is B0, B1, B2, B3. This is A0, A1, A2, A3. Anyways, let's go down the list. So 0 plus 0 equals 0. 0 plus 5. Looks like it's 5. That's cool. Negative 7 minus 0. So negative 7 minus 0 is boom, boom, negative 7. Oh, and also the little switch. So when that's on, when this is on, when it's up, it means that it's a minus instead of a plus. So its default state is a plus, and when it's on, it's a negative. Anyway, so negative 7 minus 0 is negative 7. That's great. Okay, 2 plus 4. 2 plus 4 equals 6. Negative 2 plus negative 2. So that's boom. Oh, that's close. Okay, yeah, negative 4. 7 plus negative 4. So 7 plus is here, like that. And then a negative 4 is a 1, 1, 0, 0. 7 plus negative 4 is 3, which makes sense. Negative 6 plus 1. Okay, so 101. So 101. Get negative 6 plus 1, and then 0, 0, 1, 0, 0, 0, 1, which would equate to a negative 5. 5 plus 6. So that's 6, and this is 5 plus 6. And that will not be valid because if you add up 5 plus 6 here, it would equate to 1, 0, 1, 1. In which, since it has a 1 at the third bit, it would make it so that it'll say it's a negative number when in reality it shouldn't be. So therefore, it's not valid, which makes sense. Anyways, let's go to the next of the list. So negative 8 minus plus negative 1 should be, give me one moment. So negative 8 plus negative 1. Oop. Oh, wait. Yeah. And that's also not valid because negative 8 plus 1, if you add all these up, right, it's going to have it so that the output, the third bit, or I guess the fourth bit, but the third bit would be equal to 0, which would say it's a positive number when in reality it should be a negative 9. Anyways, 6 minus 5. So 6 minus 5 should equal 1. And that's a negative, and that looks right. Yeah, 6 minus 5. Negative 3 minus negative 5. So let's do that. So minus 3 is 1, 1, 0, 1. So minus 3 and minus 5, which is 1, 0, 1, 1. Which would make sense because it'll be negative 3 plus 5, which would equal 2. It's not negative 2, it's just a 2. Anyways, let's go down to the next list. 2 minus 5, which would be, let me just turn all these off. So 2, which is right here, 2 minus, that's on, minus 5. So it's going to be 1, 0, 1, 1, which would equal 7, which makes sense. Okay, next on the list, -5 minus 3. So hopefully it's going to output at -8. So -5 minus 3. So that's a 1, 0, 1, 1. So that's a -5 minus 3, which would be these, which would equal 8. Well, -8, because that thing's on. Makes sense. -8. Last two, so -1 minus -8. So let's do that. So that's 1 minus -8. And that would not output anything, because this is supposed to be, well, 1 minus -8 would equal +9, right? Well, equal 9. And if you have this so that these add up to each other, it's not going to be so, in which it's going to be 1, 0, 0, 1, in which it's going to say it's a negative output, when in reality it should be a positive output. So that's why the LED is not on. Now finally, -4 minus 6. So -4 minus 6. Okay, so let's get the 6 out of the way. Okay, and then a 1, 1, 0, 0. Okay, and this is not valid because, well, it's supposed to output a -10, right? And I guess it can't because of the fact that, hey, it is, even though it is valid, I believe. Wait, give me one moment to look at this. So 0, 1, 0, 1. It should be valid, but wait. 0, 1, 1, 0. That should be -10. Oh, wait. 0, 1, 1, 0, 1, 0. Oh, so then when you add these two inputs, it's going to have the fourth input, or the third, I guess. This part would equal 0, even though it should be -10. Therefore, it's not valid, and therefore the LED is not on. Anyways, thank you very much.